All right, today we're diving into something pretty wild, a technology that's basically copying nature's homework to completely revolutionize automation. We're talking about swarm robotics. Let's get into it.
So let's just start with this idea right here. Picture it, a warehouse. But instead of one huge, complicated machine, you've got hundreds of small, simple robots moving together like ants. It sounds like something out of a sci-fi movie, right? But this isn't fiction. This is the exact idea that's shaking up whole industries as we speak.
And you know that vision? It's not some far-off future thing. It's happening right now. And the most famous place you'll see it is inside those gigantic warehouses that get your packages to you.
Yep, we're talking about Amazon's warehouses, using a system that originally came from a company called Kiva. Think about it. Instead of workers walking for miles and miles down endless aisles, you've got thousands of these little orange bots that bring the shelves to them. And here's the crazy part, the real magic. There's no central brain, no air traffic controller telling them all what to do. They just figure it out. They coordinate on their own, avoiding traffic jams and adjusting to how busy things get. It's wild.
So that warehouse example, it's really just the tip of the iceberg. It points to a much bigger idea, a totally different way of thinking about automation. I mean, it's a fundamental shift from how we've always built and controlled robots.
Okay, this chart really nails the difference. So, traditional robotics. Think of it like a body with one brain. If that brain goes down, the whole system just stops, dead in the water. But with swarm robotics, it's completely decentralized. Every single robot is making its own decisions. So what happens if one of them breaks down? The others just keep going. They work around it. This makes the whole system unbelievably resilient. It's fault-tolerant. Plus, you can just keep adding more robots to the team without gumming up the works. It scales beautifully.
So where did we get such a brilliant idea? Well, we didn't exactly invent it from scratch. We stole it from the best engineer there is, nature. Seriously, we're basically copying the blueprints from ant colonies, bee swarms, flocks of birds. I mean, these are systems that have had millions of years to perfect this whole collective intelligence thing.
Okay, that's the big question, right? How in the world do you take the behavior of an ant colony and turn it into computer code? Let's dig into the secret sauce, the surprisingly simple rules and clever algorithms that make these swarms tick.
The absolute key concept here, the one thing you really need to get, is this idea called emergence. It's where the whole is so much greater than the sum of its parts. See, the system's intelligence, its genius at organizing a whole warehouse or finding the perfect route, it's not actually programmed into any one robot. It just emerges from all of them interacting and following a few dead simple rules. And when I say simple rules, I mean really simple. Just look at this. For those warehouse robots we were talking about, it basically comes down to these 4 instructions. That's it. Each little robot just follows this super basic script, and boom, out of that chaos comes this incredibly efficient, self-organizing logistics network. There's no grand master plan. It just happens.
Let's look at another classic example to see how this works. You've all seen a flock of birds, right? How they move as one? Well, that's an algorithm too, and it's based on just 3 simple urges. Rule 1, separation. Don't crowd your buddies. Rule 2, alignment. Kind of point in the same direction as everyone else. And rule 3, cohesion. Try to stick with the group. That's literally it. Those 3 simple commands are all you need to create that beautiful, coordinated movement we see in the sky.
Okay, this next one is just brilliant. It's how swarms figure out the best way to get from A to B. It's called ant colony optimization, and it works exactly like it sounds. When a robot finds a good, fast path, it leaves a little digital breadcrumb trail, a pheromone trail. The better the path, the stronger the trail. Pretty soon, more and more robots start following the strongest trails, making them even stronger. And the bad paths? They just get ignored, and their trails fade away. The swarm literally teaches itself the most efficient route. It's incredible.
So, we've seen the theory, which is super cool. But what happens when you take these clever, nature-inspired algorithms and actually unleash them in the real world? Well, let's take a look at the impact this tech is already having. And trust me, the numbers are staggering.
All right, let's talk numbers. First up, raw productivity. In those warehouses we mentioned, the ones using swarm systems, they're seeing a 50% increase in picking efficiency. That means they can fulfill your orders up to 50% faster. That's a massive jump.
And of course, a huge jump in productivity like that translates directly into savings. We're talking about companies cutting their labor cost for those boring, repetitive tasks by 40 to 60%. That's a game changer for any business.
But honestly, this next number might be the most important one of all. 90% uptime. Think about that. Because the swarm is fault-tolerant, if one robot goes down, the mission doesn't stop. The system basically just heals itself by having the other robots pick up the slack.
That kind of reliability is something you just can't get with a traditional centralized system. It's almost unheard of.
And when you have that kind of insane reliability and efficiency, you can bet it's not going to stay locked in a warehouse. It's no surprise this tech is exploding into other fields. In manufacturing, you've got companies like BMW using swarms to create super flexible assembly lines. In agriculture, they're being used for precision planting and weeding. And get this, in construction, they're even working on swarms that can build things in environments that are way too hazardous for people.
Okay, so what's next? Where does this all go from here? I mean, the technology is obviously incredibly powerful, but it's not all smooth sailing. There are still some big challenges we need to figure out as we head toward a future where humans and these swarms work even closer together.
For starters, just imagine trying to manage the communications between thousands or maybe one day millions of these things. That's a massive technical hurdle. Then there's security. How do you make sure these decentralized networks can't be hacked? And maybe most importantly, we have to figure out how to make it safe and, not weird for people to work right alongside them.
But the work on the next generation is already happening. We're talking about swarms that use AI to actually learn from their mistakes and change their own rules on the fly. Picture this, a human operator just using simple voice commands or hand gestures to direct an entire swarm. Or even better, a system where humans and robots are true teammates, deciding together in real time who's best for each part of a job. That's the future we're heading for.
And that really brings us to the big takeaway here. This whole thing, it's not just about building smarter robots. It's about a completely new way of working together, a new model of collaboration. Because as these intelligent collective systems pop up everywhere, the question for all of us isn't if we'll work with them. That's a given. The real question is, how will our own jobs, our own roles, have to change and evolve to keep up in a world where being part of a team isn't just a human thing anymore?